Well, this happens with great regularity. I made another careless error. I'm just careless with my R out. There's a 5.4 in there, right? And when I multiplied this out in my demented imagination, I thought I was done. I didn't think. It was as if I was done with the 5.4. Clearly that's not the case. So this should be minus portion. I can make a minus sign into a 4, right? Look out there. So we have a negative 5.4, and that negative 5.4, of course, needs to go here. Okay? So that's going to put a 5.4 in front of Q here. And here, and here, and here. So then we're going to be dividing by 5.4 when we get to here. Of course, we're going to have a reciprocal 5.4 out of this, right? So we're not going to be dividing, we're going to be multiplying by 5.4. So we're going to have this, it's going to be over 5.4. Okay? That's going to affect our value of A, it's going to affect this term. Actually, it's not going to affect this term. It's going to affect our value of A and affect this. Now, I'll just ask you, okay, fix it. That's a good exercise since this question came up spontaneously. No excuse here. You're still going to get something much like this. I'll leave it to you to figure out whether that's actually going to change or not, but it's pretty clear that it's not, because that doesn't affect what you get over here. Okay? Because this came from dividing by the negative v here, right? Yeah. And that's not affected by whatever coefficient we might have here. Actually, never mind, it would be affected because you're going to have a negative v over 5.4, right? You're going to have a 5.4 here. Okay? So you can think about what that means, but what does this look like? At e to some multiple of a sine t, whether it's positive or negative. Well, okay, you've got sine t, right? E to the sine t, and you can graphically do a composite like this, but I'm just going to do it with numbers. Okay, so here's 1, here's negative 1, right? Now, when the sign is 0, e to this thing is going to equal 1, right? When the sign is 1, or whenever this term becomes 1, so this could be your sine t over v with all the other coefficients. Whenever this equals 1, you're going to have value e. When this equals negative 1, you're going to have value 1 over e. Okay? So this thing is going to oscillate from here to here, down to here, back up to 1, then back up to e. And the graph is going to look like this. It's a distorted type of sine function that never reaches 0, right? And that's going to be a factor here. In this term, and that doesn't seem right either. you shouldn't be multiplying this by something that looks like this, because in the long term, the oscillation of this thing is going to, oh, wait a minute, now I'm doing e to the sine t over v, right? E to the negative sine t over v would be the reciprocal of that. Okay? That doesn't help. Okay, so something's wrong here. So I'll let you think about it. Okay? There might be another error in there someplace. If you do everything carefully from here, you'll get something. What's bothering me here is that and it's not e to the negative, it's e to the sine t over v. Okay. But it wouldn't matter if it was negative, you'd still have the same type of curve, it'd just be shifted a little bit. What's bothering me is that this really shouldn't be a factor here, because the fact that your flow rate is increasing and decreasing while still remaining positive and still averaging double the 5.4 gallons per minute. This has a huge effect on the result, and it shouldn't. Okay? So you can think about what that would be. The other thing is, what's the period of the sine or cosine function? Yeah, your period is, well, on the t-axis, right there's 2 pi, right?
Yeah.
Now, if this is in hours, that means you go through this whole cycle about every 6 hours, right? Okay? So, the equation, if you write it down correctly, is actually quite simple, and you can solve it. Interpreting the solution, I find that real bothersome. Oh yeah, the other thing though is, this is multiplied by the decreasing exponential, right? So that won't have a huge effect, because pretty soon, or at some point, this is going to become pretty minimal. Okay, so that's your e to the sine t over v. Your e to the negative 2t over v, e to the sine t over v, is going to be kind of superimposed on an exponential, a decreasing exponential, that kind of looks like this. In other words, this whole thing is going to be enclosed in one of these, giving you an ultimate solution that will look something like and I drew that carelessly, be up here. Okay, decreasing exponential that like starts here and decreases, comes back to a maximum here, decreases some more. Just a decreasing oscillation.
Yeah, I think. Sorry.
That's okay.